We are Design Team 2, and we are working on streamlining the transabdominal ultrasound transducer for IVF oocyte pickup. Early in the semester, we conducted ethnographic observations at UPMC Magee Women's Hospital for their clinical workflow. We watched physicians attempt transabdominal retrieval using both the single transvaginal probe, which is too small and ergonomically difficult to use abdominally, and the traditional two-piece abdominal system, which requires two clinicians to operate. These limitations create inefficiencies and reduce procedural consistency. Identifying these challenges is what led us to embark on designing a single clinician transabdominal needle guide attachment.
Once we defined the clinical problem, we began conceptualizing how a single-piece needle guide attachment could integrate with existing transabdominal probes. Our first physical step was building a low-resolution foam core prototype. This allowed us to explore basic dimensions, attachment concepts, and user ergonomics without committing to any detailed design. The foam core model helped us visualize the overall geometry and quickly gather feedback from clinicians on shape, placement, and usability.
After refining those early ideas, we moved into what we called our killer experimentation phase. Here, we tested only the essential must-have functional features using a tofu phantom to simulate abdominal tissue. The goal was to determine whether attaching and detaching a guide could be done quickly and smoothly with one hand, and whether the geometry allowed consistent needle alignment. These tests helped us eliminate unnecessary features and identify the minimum viable characteristics our design absolutely needed to succeed.
Our killer experiments, we have moved forward with a medium resolution prototype. We 3D printed a more refined needle guide attachment that allowed us to evaluate realistic material behavior, tolerances, and overall fit on the transducer. This prototype enabled more accurate testing of the attachment mechanism, ergonomics, and structural stability, and it helped us identify design revisions for our next iteration.
As our design developed, we conducted a comprehensive hazard and risk analysis. We evaluated potential failure modes such as improper assembly, mechanical instability, material degradation, and any theoretical risk of electrical shock or interference with the transducer. This analysis allows us to define safety mitigations early, ensuring that the device would be compliant with clinical expectations and reduce user error as much as possible.
Moving forward, our last major phase will be verification and validation testing. Verification will ensure that our design meets all of our defined functional and performance requirements, including stability, cleanability, and clinician compatibility. Validation will confirm that clinicians can use the device effectively in a real procedural setting. Together, these steps will guide us toward a final, safe, and clinical meaningful solution for single clinician transabdominal egg retrieval.